So a set is a collection of distinct objects, things, or numbers. The object which make up the set is called the element. So see what we are looking at. Okay, for instance, a set A contains elements A, B, C, D. So if you have a set that contains A, B, C, D, we normally denote it by this. So A is the set. So once you write the items inside called the members, you enclose it in a curly bracket. So that's the bracket that we use in sets. We don't use this type of bracket. So this is not a set. If you see something, if someone writes A is equal to A, B, C, D, so this is not a set. So it must be this type of bracket, curly bracket. So that's it. So each of these is called the element or the member. So which is A is the element of A, B is an element of A. So that's it. So the next thing is the characteristics. Okay, we have that the first thing we have to know under it that the elements are enclosed in curly bracket, as I've said before. While the second one, the elements are separated by a comma. So once you write a set, maybe if you write set P is equal to, you cannot just write the element like that. No. So this thing means just one item, so you need to separate them with a comma. And no element is repeated. Yes, we don't repeat element in sets. Maybe if you have a set that has maybe B 2 times, so this is not allowed in sets. As you can see, we have 2B, but we don't write it in sets, we just write one of it. So that's this third characteristics. And the fourth one, ordering of element is immaterial. So we don't order like this. We can still write the set P as B, A, D. So order doesn't matter. So that's the major 4 characteristics of set. So the next one is now representation of set. So to represent set, we use 2 methods, by roster or listing method. This will list 1 1. As you can see, the elements are A, B, C, D. We list. Or the second one, we use set builder notation. Like this, they said B. The set inside B must be a multiple of 6 within this boundary. Do you get? So that's another way of writing set. So whenever you have a multiple of 6 within this boundary, that's between -2 and 20. So that's another way of writing set. It's called set builder method, or you list. So we're done with method of representing set. So the next one, types of set. So under types of sets, we have finite set. That's a set that you can list the elements. Yes, that has a finite number. As you can see, A, B, C, D. You can list it. Infinite set is the one you cannot list. Yes, that has infinite number of elements. Like this, B is a multiple of 6. So we have a lot of numbers that are multiple of 6. So you can list. So why we have null or zero sets? So a null set is a set with no elements. So if you don't have any element or member inside, so it is denoted by this, an empty curly bracket or this. So once you see this or this, it means a null set. So there's what we call singleton. Singleton is just a set with one member, as you can see, one element. So that's what we call singletons. So we'll look at the terms used in sets. Okay, terms used in set, we have subsets. So if you have 2 sets, A and B, that's A and B are 2 sets. If every element of A is in B, then A is called the subset of B, and it's written this way. So A is a subset of B. Thus A is a subset of B. A in B, or B contains A. We can also write it as B is a superset. So this, the opposite of this sign, is the superset. So B is the superset of A, means that B contains A. That's the same. So if A is a subset of B and there exists at least one element in B which is not in A, we can then say that A is a proper subset of B, or B is a proper superset of A. So it's written, if you notice, there is no, I would like to call it equality down here. See the difference? So this means that A is a proper subset. So see what I'm saying? You can see that maybe if you have set A with element 1, 2, 3, and you have B with element 4, 5, 1, 3, 2. So we can see that every element of A is in B. So we now say that A is a proper subset of B. But if maybe if A is this and B is just maybe, okay, let's use another. If P is A, B, C, D, or maybe just A, B, and Q is A, B, C. So we can say that P is a subset of Q, but not a proper subset. So do you see it? That's the difference. This one has an extra element aside the ones in A. So that's what we are saying here, that if B has an extra exists, that's if there is at least one element in B, we say that A is a proper subset of B. So that's it. So the next one is universal set. A set from which all other sets under consideration in a problem are drawn from is called a universal set. It is denoted by this, though we have a second sign symbol for that. Some textbook they can use this, so either you use mum or that. So see what I'm saying, that if you have this called a universal set, if you notice that zooming is a universal set if you have the element maybe 1, 2, 3, 4, 5, 6. You now have other set, maybe that's subsets. Maybe if you have 2, 3, maybe another set, maybe 5, 6, maybe another set R, maybe you have 4, 5, 6. So you notice that all these sets E, Q, and R, they are all gotten from this set. So this is called the universal set. So that's the meaning of universal set. So why complement of a set? The complement of set A is a set that contains the elements that are not in A but in the universal set. It is denoted by A prime or A raised to power C. So see what I'm saying? Looking at this, see our universal set. If you look at P has element 2, 3. So if you want to get the complement of P written as P raised to power C or P prime, means that the elements that are in universal sets but not in P. So any other element that are in the universal set but not in P is called the complement. So look at that, like you can see 1 is not in P, 2 is there, 3 is there, so 4 is not there, 5 is not there. See, so this is the complement of P. And maybe let's do R or Q complements. So we have 5 and 6 in Q. So other element, which is 1, 2, 3, 4, are the complement. That's it. That's the complement of that. Why finally? The complement of, you can write R prime. They are the element that are in the universal set but not in, so which is 1, 2, 3. So these are the complement of this set. So that's what we mean by complement of a set. So there's what we call cardinality of sets. So we normally write it as That's like absolute value of A. It's just the number of elements of a set. It's called the cardinality. As you can see, like this, the cardinality of P. So if I say the cardinality of P now means the elements here. How many elements are there? So it's a number 2. Why the cardinality of Q? How many elements? We have 2 again. Why the cardinality of R? How many elements? 3. So it's just a number of, once you count the element, the number is the cardinality. Okay, the next term is the power set. So the power set of A, that's a set A, is the set of all possible subsets of A. It means that is the set that can be formed using the elements in the set A. It is related to cardinality as the power. So that's the symbol for power set. So power set is giving us 2 raised to power n, where n is the cardinality. Okay, let me explain. So see what I'm saying. Assuming you have sets, maybe that A has elements, maybe A, B, C. So if you have power set of A, it's just that the set that can be built using the elements there. So it contains all the subset of this. So see what I'm saying? Like you can build a set with an empty set. Yes, it's also part of the set. An empty null set. Yes, we can build it as excluding an element. We can still have set A that contains only element A. We can still have B. We can still have set C. Yes, we can still have A, B. We can still have B, C. Yes, we can still have AC. And finally we have A, B, C. So how many? 1, 2, 3, 4, 5, 6, 7, 8. Yes, power sets. So from this formula you can still get it where n is the cardinality. Remember I told you n is the number of elements. So the answer from this is the answer is 8. Or you can still solve it as 2 raised to power n, where n is the number of element 1, 2, 3, which is 2 raised to power 3. So without wasting time getting all this, we can still use this formula. So that's the meaning of power set. So the other one is the difference of 2 sets, or relative complement of sets. So the difference is just that if you have 2 sets and you notice that there is an element in one that is not in the other one. So I'm saying that if you have set A and B, A minus B means the elements in A but not in B, or you write it as this, or you write it as this. So they mean the same thing. So see what I'm saying? If you have maybe if you have set A to be maybe 1, 2, 3, 4, and set B to be 3, 4, 6. So if I have A minus B, means the element that are in A but not in B. As you can see, 1 is there, 1 is here but not here, 2 is there, okay, none. So we have only 1, 2. So that's the answer. So that's the meaning of difference of set, or relative complement of set. So the other one is called the Cartesian product of 2 sets. The Cartesian product of set A and B, written as A times B, is the set of order pairs from A to B. Yes. So see what I'm saying, that if we use P, if I have P to be X, Y, and Q to be 1, 2, 3, that's the element 1, 2, 3. So if I want to get P, the Cartesian product of P and Q, it's just that I will build a set using this P followed by Q. See what I'm saying? We'll start with X. 1. That same X. 2. So what do you notice something? So I'll count X P before Q. Also we have 3 remaining. X, comma 3. So we are done with X. We start with Y again. Y 1, Y 2, Y 3. So that's it. So let's do for Q, Cartesian product of Q and P. So we start with the first element here is 1. So 1 comma X, 1 comma Y. We are done with 1. We start with 2 comma X, 2 comma Y. We are done with 2. We now do finally 3X, 3Y. So that's the meaning of Cartesian product. So the other one is equivalent of sets. Two sets are equivalent if they have the same number of elements. Yeah. Maybe if you have set A, B, C, Y set B, 1, 2, 3. A and B are equivalent set because both of them have the same number of elements, 3. And 3, 3. That's the cardinality is 3. So if they have the same cardinality. So equality of sets. Two sets are equal if they have the same number of elements. Yes. So if you have maybe P is 2, 3, 4. YQ is 3, 4, 2. These two sets are equal. P and Q are equal because they have the same elements. See, 2, 2, 3, 3, 4, 4. So you matter the arrangement. Once they have the same element, they are equal. So we have intersection of sets. The intersection of 2 or 3 sets is the set that contain the element common to the set. It is denoted by like an inverted cup. So see what I'm saying? If you have maybe with 2, 3 and 4 and N with 2, 5, 6. So if you want to get M intersection N from the definition means the element that is common to both. As you can see, both of them have 2. So that's the answer. So element that have the same that contain in both sets is the intersection. So Y finally union of sets. The union of 2 or more sets is the set that contains all the elements in all the sets. So if you have set A 4 and you have set B maybe 0, 2, 4, 5, 6, 7. To get A union B is like joining the two sets. So we start 0, there is 0, there is 1. Remember that we don't repeat elements. So there is 2, there is 3, there is 4, there is 5, 6 and 7. So that's it. If you notice, see for A 1, 2, 3, 4, 1, 2, 3, 4, for B 0, 2, 4, 5, 6, 0, 2, 4, 5. So that's the union. Okay, we'll be looking at laws of sets. We have 6 of them. So that these are the laws: commutative law, associative law, distributive law, idempotent law, assumption law, and De Morgan's law. So let's look at them. So the first three is commutative. So if you have two sets such that A union B, that's after solving A union B is the same as solving B union A, like A plus B is the same as B plus A. So for union and intersection, they're the same. So that's commutative law. Why associative? It doesn't matter if you have three sets, you can take two at a time after. That's find B union C. Finally, you now find A union the result. You have to notice that the symbol here and here must be the same. That's it. If it's intersection, intersection. Union, union. So it's just change of bracket. Instead of doing B union C after, I will now do A union the result. I can decide to do A union B after, the result union C. So that's the two laws. Do you get? It's just like shifting this bracket to operate on the first two before the last. So that's the associative law. Why distributive law is like opening of bracket if you ask to multiply two terms. If you notice the symbol here and here, and they are different. Union, intersection, intersection, union. So it's like multiplying. Let me use the example so that maybe if you are asked to, let me use example. If you have 2 times 4 plus 5, if you open this means 2 times 4 plus 2 times 5. So that's what is happening in distributive. A union B intersection is like the plus. So I'm using this so that you remember it. That's distributive law. See it. A intersection B union A intersection C. So that's it. Though it's easier to solve this than this. So in some question they might give you this and ask you to solve. So you better move it to this. It's easier. So let's finish the last three. So we have idempotent law. Idempotent law is just intersection of A intersection A is the same as A. They are the same. Why A union A is A. So that's idempotent law. Why assumption law? A intersection its complement is a null set, because we know that a set and its complement will not have the same member. So it's a null set. So the same thing, A intersection A union B. A union B is just combining A and B. So A intersection, so what is common in both will be A now. So that's it. That's why it's A. So that's assumption law. Why De Morgan's law? A intersection B prime is the same as assigning the prime to both, but you now change intersection to union. Likewise union here, you change it to intersection. So that is our De Morgan's law. So let's look at one question to see how we can use it. They say given that the universal set is this, A is this, B is that, C is that, we're asked to find this. So what I will do, I need to use roster method for C. So let's list this from 3 to 9. So element of C is 3, 4, 5, 6, 7, 8, 9. So that's the first thing. So coming to the first question, they say A intersection B complement intersection C complement. Now I can move this to A intersection, De Morgan's law. So we can move it to B union C on. Okay, you can easily see that B union C is the universal set. Check it. B is 2, 3, 7, 9. Why C is this? Is the universal set. So we have, meaning that the prime will now be null set. So this is now intersection null set. Or this is B union C is a universal set. So A intersection null set is null set. So why the second one? We're asked to find A union B intersection B union C using our, you can see this is equal to using, because if you notice B is common in both, using commutative laws. A union B is the same as B union A. So intersection B union C. Yes, they are the same. A union B from the commutative law. A union B is the same as B union A. So, and if you notice, it's the same as using distributive law. Is now B union A intersection C. Check it. It's now B union A intersection B union C. So we use commutative and distributive law. So because it's easier than doing this. So see that A intersection C. So what is common? Okay, let's write B is 2, 3, 7, 9. Union A intersection C. So what is common in A and C? So this, as you can see, I'm seeing there is 4. There is 6. And there is 8. So what is the union of this? This is now 2, 3, 4. There's no 5, 6, 7, 8, 9. So that's our answer. So it's a very nice question. Okay, we look at Venn diagram. Venn diagram is just a diagram used to represent a set. Yes, it helps us to solve a lot of word problem in set. So let's look at the definition. Okay, a Venn diagram is a diagram used in representing a set. It consists of circles enclosed in a rectangle. The circle represents the subset and the rectangle represents the universal set. Okay, so that the major information here must be circles and also a rectangle. The circles are the content of the universal set, that's the subsets. So see what I'm saying? See a typical Venn diagram. Yes. So from this, you can see that we have a rectangle. This rectangle is the universal set, that's the container. It contains all the subsets. So maybe if we call this A, B and C. A, B and C are the subsets, yes. So, and you can see there are some spaces here. These are the elements. The elements that you don't find in A, B or C are outside here. So this is the universal set, which is the container. Let's look at special Venn diagrams. Very important. Okay, look at this. This is a very nice Venn diagram. As you can see, there is a shaded region here. This region is common to maybe if you have set A, B and C. So this region is this region that contains the elements in A, B and C. So we can write this as A intersection B intersection C. Yes, that's the shaded region. So this place contains elements that are in both in A, B and C. So why this? If you notice, okay, if you call this A, if we call it, maybe let's call P. Okay, let's use A, B, C. Here, you notice that the elements here are only in C. So these shaded regions are elements in only C. So we'll now write it as A intersection B intersection C. So since we have only elements here, so we'll put other ones prime. So we don't need the ones in A and B, so only in C. So that means A prime intersection B prime intersection C. So that's the Venn diagram. So coming here, if we name this to be A B, and C. So if you notice, you have elements, the shaded regions are the elements inside B and C, but not in A. CA. There is nothing in A that is in this. So we'll write it as, you first write A intersection B intersection C. Since we are talking about the ones in B and C, so we map out A. So A prime intersection B intersection C. Why this means element in all, like union. So this is A union B union C. If we label this as A, B, and C. So finally, yeah, this is the opposite of the other one. So if we label this, if we label this to be A, B, and C, you notice that the shaded regions are the element outside A and B and C that's joined together. So we can write this as A union B union C is when it is shaded. All these places are shaded. But since we are not looking at that, this is the prime. So that's it. It has to draw a Venn diagram. But let's now solve just a simple question to illustrate Venn diagram. So look at, they said out of 6 beds in a certain location, 20 are passerine and 23 are Arctic 10. If it is possible for a passerine to be either Arctic 10 or not Arctic 10, then the number of 60 beds that are neither passerine nor Arctic 10 is dash. So this is the equation on Venn diagram, but this is now 2 subsets. So the first thing we have to do is to draw our Venn diagram. So if I have a Venn diagram with 2 subsets, okay, from this they say if it is possible for pass, so let's label this P and let's label this A. This passerine, this Arctic 10, and they say it's possible for a passerine to be either Arctic 10 or not, meaning it can have that passerine be Arctic 10, that is can be found inside this A, and also can be possible to be found out. So let X be the ones that is both passerine and Arctic, and Y is the ones that are neither passerine or Arctic 10. So our main aim is to find the number that are neither passerine, as we are looking for Y. But they told us we have a total of 60 beds, and out of it 20 are passerine. So 20, the total here must be 20, whether it's both Arctic 10 or passerine. So we must subtract the one that is common to that. So we have 20 minus X. Why this? We have 23, so we have 23 minus X. So it's now easy for us to solve. We know that if we add the ones that are only passerine plus the ones that are both passerine and Arctic 10 with the ones that are only Arctic 10 plus the ones that are neither passerine and Arctic, then it must give us 60 beds. Yes. So our main aim is to find Y. So let's solve for Y. Minus X plus X is 0. 43 minus X plus Y equal to 60. So we are looking for Y. So Y is now 60 minus 43 is 17 plus X. So what do you have to say? The ones here must be greater than 17. Yes. Because we know there must be at least one that is both passerine and Arctic. So looking at the option, the answer is that it must be greater than 16. That's the best option. So this thing must be greater than 16 since we have 17 plus x. So that is a very nice question on that Venn diagram. So that's how we apply Venn diagrams. So I will still solve more technical questions later in the other videos. Thank you. So as for two intersecting sets A and B, the number A is 20, number B is 27. If A union B, that's all in prime, is 3, and the universal set is 40, we should find this. Okay, first of all, we have to draw a Venn diagram. So this is my Venn diagram. So the two subsets, the total first, the universal set is 40, while the sets A and B. So, but before then, this, okay, they didn't put, okay, let's just put n. This design, you can still write without n. Just n, the n there means number. So we should know that from De Morgan's law, that A union B prime is A prime intersection B prime, or A intersection B all prime is A prime union B prime. So that's what we are going to use. So we're going to use this one. So what we are asked to find is just A intersection B prime. So using the second one. Now, and we don't have intersection, means any other one aside the one so let's get the intersection. So let's call it X. Since A is 20, A only will be 20 minus X, while B only is 27 minus X. Now we know that the universal set is what? 40. So 20 minus X, everything must sum to plus. Okay, here we didn't add up this. Do you see A union B prime? So union is everything here, but the opposite means prime, means not here. So meaning 3 is outside. So this 3 is outside. You get? Union means union, everything. Union B is this shaded. If you shaded all this, union is everything in A and B. So meaning aside everything in A and B, the other one, that's the prime complement. So now plus 3 must give us 40. So which is minus, and so we are left with this negative X goes to be positive. 27 plus 3 is 30, plus 20 is 50. So 50 minus 40 is 10. So X is 10. Now let's get what we are asked to. So we are asked A intersection B prime. A intersection B is X. So prime means any other thing aside the intersection, meaning this one, the other one, and this. Therefore, what we are asked to find, A intersection B is now 20 minus X plus 27 minus X plus 3. So which is 50 minus 2X. And X is what? 10. So 50 minus 20 is 30. So that's our answer, option B. So it's a tricky one, but still simple. Thank you. Okay, we are given the diagram. We ask use this Venn diagram to solve the following. So before we solve this, we need to get the unknown, which is X. And we know that from our basic knowledge that if you sum everything inside the universal set, it should be 125. Yes. So let's add up. So I have 19 minus 3x plus 7x plus 6 plus x plus 8x plus 4x plus 5x plus 16 minus 2x plus 4 must give us 125. Yes. So let's add up the numbers. 19 plus 6 is 25. 16 plus 4 is 20. 25 plus 20 is 45. So 125 minus 45 is 8. So we are done with the numbers. Let's add up the variables, the ones with the x. Minus 3x plus 7x is 4x plus x, 5x. 5x plus 5x, 10x. 10x plus 12x, 22x. 22x minus 2x, 20x. So we see that x is now 4. So we've gotten the value of x. So let's now look at the equation. They say we should find P union Q union R. P union Q. Okay, we asked to find P union Q intersection R. So before, union means, let me just draw, assuming this P and Q. This is union. Union meaning everything. So intersection R. So what is now common to R? Intersection means, so assuming R is this. So what is common to this? You notice that is this. This area is common to the both. P union Q intersection R. So the first one we are asked to find, therefore the first is now 8x plus 4x plus 5x, which is 17x. And we've gotten x as 4. So 17 times 4 is 68. So the answer is 68. Coming to the second one, we are asked to find P union Q union R complement. So the same thing, if we draw the diagram, formally, if you are to get P union Q union R, means everything, shading everything. But now they ask us to exclude R, that's the complement. So we are excluding. So what is, we need to remove anything concerning R here. So removing this, so we are left with these ones, the one in black. So that's what we are left. So excluding the ones that has to do with R. So from our diagram, it is 19 minus 3x plus 7x plus 6 plus x, yes. Which is 19 plus 6 is 25. This is minus 3x plus 7x, 4x plus 5x. So which is, we've gotten x as 4. So 25 plus 20 is 45. So that's the answer. We've solved the equation. So each time before getting the actual, solving for the actual equation, you need to get the unknown, which is x. So thank you. Okay, they said we're given this. A number of students were interviewed to find out which sporting activities they like. That's among football, basketball, and volleyball. 70% of those liked football. That's football. Total number of people that liked football. 60. Basketball, 45. Volleyball. 45 liked football and basketball. 15%. That's volleyball. Okay, let's just draw a diagram. Venn diagram. Hi, I made a mistake. Okay, they say a number of students were interviewed to find out which sporting activity they like. That's among football, basketball, and volleyball. 70% liked football, 60 basketball, 45 volleyball. So 45 like both basketball and football, 15 basketball and volleyball. So let's just draw a Venn diagram. We'll start adding up things. So this is the Venn diagram. And since we are dealing with percents, so let's the total. Let the total be 100. So the universal set, let it be 100%. Now let's start. Whenever you are adding things in Venn diagram, you start with the 3, the intersection of 3, 2 before individual. So, but let's write the distance sports. So let the first one be football, F. This is basketball. Why this is volleyball. So they said let's start with 3. So how many like the 3 sports? As you can see, they said 5% like the 3 sports. So this is 5. So now let's fill up 2. So they said 45 liked football and basketball. Football and basketball 45, meaning this should be 40. So that 40 plus 5 will give us 45. Do you see? This is now 45 football. So why 15? Basketball, volleyball 15. So here should be 10. And 25 football and volleyball. Football, volleyball. So this should be 20 to make it 25. So let's now add individuals. Since 70 like football and we have some that like other sports, so remaining should be 5 to make it 70. So add up this, should be 70. Why this is 60? Basketball is 60, so it seems it's 5 again. And volleyball 45. They're all 5, so 5, 5, 5 each. So now, okay, they asked us to the people X did not like any sport, so it's outside, so it should be X here. So let's get X. So we know that if you add everything here, it should be 100. So now if you add 5 plus 40 plus 5 plus 20 plus 5 plus 10 plus 5 plus X must give us 100. Yes. So let's check 5 to 40, 5, 20, 5, 10, 5. So to avoid mistake. So what do you observe? So this is 5, 45, 50, 70, right? 70, 75, 80, 90. So it should be 10. 100 minus 90, 10. So X is 10. So they were asked to find the percentage of students who like at most, number that like at most 2 sports. Means at most means less than or equal to 2 sports. So meaning either no sports or 1 sport or 2 sports. So now no sports is X, which is 10. Or in maths means addition, plus 1 sport is either football or 5 for basketball or 5 for volleyball. So it's either the person like football, 1 sport, or basketball or volleyball. So why 2 sports is now 2 sports, either football and volleyball, which is 20, 40 and 10. 20, 40 and 10. So that's the answer. So let's add up. Let's add, this is 10, 20, 60, 70. This is 70 plus 10, 80. 80 plus 10, 90. So 95. Let's check back. This is 70 plus 10, 8. Nice. So the answer is 95. So that's our answer. Thank you. So we're asked, in a roadworthiness test on 300 cars, 60% passed. The number that failed had fault in clutch, brakes, and steering as follows. Clutch only is 28. Clutch and steering 14. Steering and brakes 8. Clutch and brakes 20. Brakes and steering only 6. The number of cars with fault in brakes only is twice the number of cars with faults in steering. So we asked to find the number of cars with that had at most 2 faults. Okay, so we need a Venn diagram. So let's draw a Venn diagram. So that's the Venn diagram, and let's add up the things. So remember, they said 60% passed and 40 had these faults. So we're going to get the 40% that had fault. 40% of 300 is 40 over 100 times 300. So it's 120. So the ones with faults, we have 120. And remember, the universal set is 300. So since 300, we have total of 300 cars and 120 had faults. Remaining, we are left with 180 without fault. So the ones we use in forming the subset of that are the ones with fault. So let's use C as clutch, B as brakes, and S steering. So now let's add up this. Let's add things. So from here, remember, we need to be careful. We need to fill up. Is there anyone with all the faults? Is there anyone? No, they don't have all the faults. But okay, let's fill up the ones with only. So clutch only is 28. So we have 28 here. So is there any other ones? Only. Brakes and steering only. Brake and steering only without clutch. So here should be 6. Okay. So is there any other steering and brake? Okay, they have steering and brake 8. So since steering and brake only is 6, and steering and brakes without only is 8, meaning that here should be 2. So the ones with the faults, all the faults, check now. Brake and steering, C is 8. Do you see? Why the only is 6? So we are correct. So they now said, which one again? Is there any other? Okay, 14. They say clutch and steering. Clutch and steering. Clutch and steering. 14. So here is 14. Clutch and steering 14. So here should be 12. Since clutch and steering is 14 and we have 2 here, so here should be 12 to make it 14. So we need to be careful. Clutch and steering 14, so see it's 14. So which one again? They said clutch and brakes 20. Clutch and brakes 20. Clutch and brakes 20. So here should be 18 to make it 20. Since clutch and brake is 20 and here is 2, so this should be 18. So is there any other one? Okay, no. They now said the number of cars with faults in brakes only is twice the number with faults in steering only. So let let the cars with faults in steering be X, then 2X are the ones with steering only. Remember to put only, this should be only. Then 2X are the ones with faults in brakes only. So Duke said is 2 times the number of cars with steering only. So now the ones with steering is now X, brakes only is now 2X. So let's get X first before any other thing. So we know that here, therefore, if you sum the ones with fault, it must give us 120. So now we have 28, therefore 28 plus 18 plus 2X plus 12 plus 2 plus 6 plus X must give us 120. That's the one with the 4, 2, 3, 4, 5, 6, 7. Okay. So now we have 2x plus x is 3x. So let's add up the numbers. So 18 plus 12 is 30. 28 plus 2, the same 30. 30 plus 30 is 60. So 66. So 120 minus 66 is 54. Yes. So 66, that is it, 54. So for now, let's not get X, because now they ask us the main question: find the number of cars that had at most 2 faults. 2 faults, at most 2 faults. Number at most 2 faults means number less than or equal to 2 faults. That's at most means less than or equal to. So meaning that number no faults or number with 1 fault, or number with 2 faults. 2 faults. And in mathematics, we know that all means addition. So no faults, 180. So we have 180 plus 1 fault. So 1 fault here means either clutch, brake, or steering. So which is 28 plus all means addition 2x or what? X. These are 1 fault. Either is that had fault in clutch, brakes, or steering. So that's why it's 28 plus 2s plus x. Why 2 faults is now either clutch and brakes, or clutch and steering, or brakes or brake and steering. So 12 plus 18 plus 6. Yes, 2 faults. 12, 18, 6. Okay, so let's add up. This is 12 plus 28 is 40. 40 plus 180 is 220. Okay, 220 plus Okay, we've gotten 40, 220, 220 plus 24. 220 plus 24 is 244. Okay, we'll have 244 now. So 244 plus 2s plus x is 54. So our answer is 298. So the answer is 298. So that's the answer. Yes. So that is what we are asked to find. It's a tricky one, but still simple. Thank you. Okay, they say in a class of 48 students, each student must belong to 1, 2, or 3 sports clubs. If 21 belongs to basketball club, 28 belong to table tennis club, and the number that belong to the basketball club only is 2 students more than the number that belongs to basketball and football clubs only. If the number that belongs to table tennis club only is twice the number that belongs to basketball and football clubs only. Find the number of students that belong to at least 2 clubs if the number that belong to basketball and table tennis clubs only is twice the number that belongs to all the clubs, and the number that belongs to the football and table tennis clubs only is 3 times the number that belongs to all the clubs. Also find the number that belongs to only 1 club. This is a very tricky question. So what I will do, I will move to the next page so that I will draw the Venn diagram. See our Venn diagram. So let's complete it. We say let the number that belong to all the clubs be X. The number that belong to basketball and football clubs only be Y. And finally, the number that belong to football club only be Z. So that's it. So let's label our diagram. So let's call this basketball, let's call this football, and let's call this table tennis. So we say let the number that belong to the 3 clubs be X. So let's call it X. So again, they say the number that belong to basketball and football clubs only, basketball and football club only, is Y. So let's call this Y. And the number that belong to football club only be what? Z. So here Z. Let's fill up others. So from the question, they said the number that belong to basketball club only is 2 students more than the number that belongs to basketball and football club only. So we'll go to football club and basketball only is Y. So the ones that belong to only basketball will now be Y plus 2, because they say there are 2 more. Do you get the logic? The one that belongs to basketball, saying that belongs to basketball only, is 2 students more, so it's plus 2 than the one that belongs to basketball and football clubs only. Okay, look at this line. They say if the number that belongs to basketball and table tennis club only is twice the number that belongs to all the clubs. So we'll go to all the clubs and the one that belongs to basketball and table tennis. So C basketball, C table tennis only is 2 times the one that belongs to all the clubs. So this is 2x. So we're almost there. So why they said football and table tennis only? Let's go to the why they said, and the number that belongs to football and table tennis club only is 3 times the number that belongs to all the clubs. So again, here is 3x that belongs to all the clubs, because they say table tennis and football only, which is this. So they said if the number that belongs to table tennis club only is twice the number that belongs to basketball and football. So we'll go only. So we'll go to basketball and football only. Basketball and football only is y. So here is 2y. So and the total number of students is 48. So we are good to go. I'm saying. They said, look at the beginning, they said if 21 students belong to basketball club. So let's go to basketball club. If 21, so we see that 2x, all these ones under basketball, you see that 2x plus x plus y plus 2 is equal to 21. So from here you see that 3x plus 2y, 3x plus 2y is equal to 19. We'll call it equation 1. So again they said 28 belong to table tennis club. So we'll go to table tennis club. 28. So we have 2x plus x plus 3x plus 2y is equal to 28. So what do you have? Which is 3x. We have 6x plus 2y is equal to 28. So we reduce to divide each by 2. So it's 3x plus y is equal to 14. So we'll call it equation 2. So solving this, you can see that from equation, if you do equation 1 minus equation 2, we have 3x minus 3x gone, y minus y, 2y minus y is y, and 19 minus that is 5. So we've gotten the value of y. So let's get the value of x. So from equation, take any of the equation. So from equation 2, you see that making x the subject of formula, x will be 14 minus y over 3, which is now 14 minus 5. Y is 5. 14 minus 5 is 9. 9 over 3 is 3. So we found the value of x. So let's finish up. So let's get the value of z. So from there, we know that if we add everything is equal to 48. Yes. So if we add, I'm adding. So I'm adding, let's start with x. 2x, y, 3x. These are the ones, 2 spots. We've done all the spots. 1, 2, 2 spots. So let's go only one spot. So it's 1 plus 2 plus 2y plus y plus 2 plus 2y plus z is equal to 48. From here, if you add this x, 3x, 6x, so we have 6x. This is y plus y, 2y plus 4y plus z is equal to 48 minus 2 is 46. So we are looking for z, which implies that z is now 46 minus 6x plus 4y. And we've gotten the value of x as x is 3. So y is 5. X is 3, y is 5. So this is 46 minus this 18. 18 plus 20 is 38. So the answer is 8. So z is 8. So from the question they said we're asked to find the number of students that belong to at least 2 clubs. At least 2 clubs. So number at least means less than or greater than. So 2 sports less than number that are greater than or less than 2 sports will be of 2 sports or 3 sports. So that's 2 greater than or equal to. So numbers that take 2 sports. So let's look at it. 2 sports is 2x plus y plus 3x. 2x plus y plus 3x. Y or a mass is plus 3 sports is x. So we have that the answer is 2x plus 3x, 5x, 6x plus y. And we have that 6x, that's 6 times 3 plus y is 5. So we have 18 plus 5 is 23. So the answer is 23. Why the number? The second question, they said also find the number that belongs to only 1 club. So from here, 1 club means this, this and this. So 1 club is 1 sport or 1 club is now basketball only, football only, or table tennis. Also y plus 2z and 2y. Y plus 2 z plus 2y. So which is 3y plus z plus 2. 3y, y is 5, z is 8 plus 2. So it has 15 plus 10 is 25. So the answer is 25. So it's a very tricky question. It's a very nice and tricky question. So thank you. Okay, they said out of 300 students who participated in Senior Science Olympiad, 75% wrote mathematics, 30% wrote physics, and 40% wrote chemistry. If at least 1 student wrote all the subjects and 35% of the students wrote exactly 2 subjects, how many students wrote only 1 subject? Okay, the first thing I have to do, I will draw a Venn diagram. So this is our Venn diagram. So as you can see, we have 3 subjects. They say total of 300 students. So the universal set is 300. And let's call this maths. Let's M be maths, P be physics, and C be chemistry. So let the number of students that that wrote maths and physics, I'm using their first letters, maths and physics, physics and chemistry, maths and chemistry, and finally maths, physics and chemistry be X, Y, Z and W respectively. Do you get? So I'm saying that X is for people that wrote physics, maths and physics, Y, physics and chemistry, Z, maths and chemistry, and finally maths, physics and chemistry, W. So this is X. Physics and chemistry, Y, maths and chemistry, Z, and finally W. All the three subjects. And they told us that 75% wrote mathematics. So the people that wrote mathematics is 75% of 300, which is 75 over 100 times 300. So we have 225. Y physics is 30%, so 30% of 300, which is 30 over 100 times 300. So we have 90. Finally chemistry, they said 40%, so 40% of 300 is 40 over 100 times 300, so we have 120. Okay, let's move to another page so that we finish up. Okay, so meaning that, remember, this 225, 90 and 120, they are the numbers that wrote mathematics. Total number for mathematics is 225. Total for physics is 90. Why total for chemistry is 120. So for the people that wrote only maths, will now be 225 minus, that's here now, is now 225 minus this ones, which is X plus Y, S plus W plus Z. Why the one that wrote only physics will be 90 minus X plus W plus Y. Y finally for chemistry will be 120 minus W plus Z plus Z plus W plus Y. So these are the ones that wrote only them. So from this we can see that if we sum all this, we need to get 300. So we are saying that therefore, let's partition this. Therefore 225 minus X plus W plus Z, that's the people that wrote only maths, is this, plus the people that wrote only physics, which is 90 minus X plus W plus Y, plus people that wrote only chemistry, which is 120 minus Z plus W plus Y, plus people that wrote two subjects, which is X plus Y plus Z. Finally, people that wrote or this, sorry, which is W, must give us 300. So let's now find their sum. So we have 225 plus this 210. 210 is 435. Why I have minus x is minus 2x plus x is minus x, so I have minus x. Okay, let's do for y. This is minus y is minus 2y plus y is minus y, so minus y. Y for z, this is minus z minus 2z plus z is minus z. YW minus w minus w minus w is minus 3w plus w minus 2w, equal to 300. So what do you have to do? I can factor this as x plus y plus z minus 2w is equal to 300. Okay, but from the question they said that 5% of the students wrote exactly 2 subjects. So let's get, they said, but x plus y, that's 2 subjects, is s plus y plus z, is at 5% of 300, which is now 35 over 100 times 300. The answer is 105. So x plus y plus z is 105. So we'll plug in. So we have 435 minus 105 minus 2w must give us 300. So we have, this goes over to that side to be 2w. Why this comes over? 435 minus 105 is 330. 330 minus 300 is 30. So w is 15. So we have 15, the number of people that wrote all the subjects. So they asked us to find, that's how many students wrote only one subject. So common sense will tell you that if you add the people that wrote one subject, which is this and this, plus people that wrote 2 subjects, which is this and this, and finally people that wrote all, it will give us to 300. So I'm saying that if we add number that wrote only 1 plus number that wrote 2 plus number that wrote all, it will give us 300. Yes, so we asked to find the number that wrote only 1, which is now 300 minus number that wrote 2. Minus, okay, maybe plus number that wrote all, so which is 300 minus how many students wrote 2 from our calculation, that is x plus y plus z is 105. 105 plus how many that wrote all, which is w, 15. So this is 300 minus 105 plus 15 is 120, and 300 minus 120 is 18. So that's it.